So grammar definition is very similar to the definitions that we have read earlier. If you remember, in Mealy and Murray machine, there is something called a six tuple definition, and there is in NFA there is five tuple definition. Okay, so in the same way, the grammar definition is a four tuple definition. Okay, so the definition of grammar goes like this: that there are four tuple, that is VT, and PS. Okay, so it can be arranged in any kind of format. So NT, SP, it's the same thing, and there is no, I think N is not there. Just let me see. VT, P, and S. Okay, so just let me see. Yeah, okay, so there is extra there. This is this. Okay, so okay, so there is extra. So I will tell you about this. Both of the notations are readily used, because if you see here, it is also written here like V. Okay, so N can also be written like a V. In most of the books, V is used. So I will most preferably be using a V. So V means a set of variables that are non-terminal. Okay, so non-terminal, if you remember, if you draw a tree, and there is something called a leaf node and a non-leaf node. Okay, so the non-leaf node is your internal node, and the leaf node are the end nodes. Okay, so this is my leaf node, and this is my leaf node, and this is my leaf node. This is also called a terminal node. If you remember, if it's also called a terminal. Terminal means the ending of a tree, end node of a tree. Okay, so it means that there is no particular child attached to that particular kind of a node. So that particular node is called a terminal node or a leaf node. Okay, in context of trees, you call it a leaf node, or it can also be called as a terminal node. Keep that in mind. It can also be called a terminal node. And if it is not in the end, this particular, you can say that this particular node is non-terminal node, or it is also called a non-leaf node. Okay, based on the same context, the definition is defined here. It is just saying that n is a set of variables. It is just a set of variable. V is a set of variable, and the most of this, it is non-terminal symbols. Okay, so non-terminal symbol is the capital symbol. Keep that in mind. Non-terminal symbols are all the capital symbols. Okay, so capital means A, like written like this: A, B, C. So if it is small a, it is not a non-terminal symbol. Keep that in mind. Okay. So now the second T is T. T is also called a terminal symbol. And see, if it is ending with, if you are clearly seeing the definition of trees, you will see that a terminal node is the node. After that, there is no node. So the ending point of a particular thing is called a terminal node, and the terminal symbol is denoted by a small ABC. Okay, so small letters. It can be like A, comma B, comma C. Keep that in mind that the non-terminal is capital. I will tell you why it is capital, and I will tell you why it is small. Don't worry about it. Still, just see that the terminal symbol are small letters, and the non-terminal symbols are big letters and capital letters. Okay. In the same way, there is something called a start symbol. So whenever, if you remember the start states of finite automata, in the similar way, there is a start symbol for a particular grammar. Okay, so for grammar also there exists a start symbol. So suppose this is a grammar that I've wrote, s equal to a. So the start symbol for this grammar is particularly s. Okay, so there is no compulsion that you will also always use a s. I can say that a equal to a equal to ab, and b equal to something like this, b equal to small b. And now the start symbol in this particular grammar, s is equal to a. So keep that in mind that there is no compulsion that the variable will always be s, but it is most generally denoted by s. Okay, so if s is written in the language, it will most probably be the start symbol. But start symbol can always be identified by looking at the production, that where from which particular variable it is starting from. Keep that in mind. Start symbol will always be non-terminal. So it will always be a capital letter. So it will always be a non-terminal. Okay, so don't confuse it. Terminal and non-terminal bit, I will tell you in a little bit of time. So do not try to remember it. I will tell you a little bit of a trick to remember that what exactly is the meaning of terminal and why a terminal node is a capital node. Okay, so now there is something called a P, that is production. Okay, so I will tell you about the production. Just I take an example and I will tell you what exactly is the production rules. Okay, so now just see, this is an example of a grammar. So just take this grammar. I just write it like this: as equal to AB. So this is a particular grammar. Now why I call this a grammar, I will tell you about it. So this is a grammar. Okay, so why how can you identify that this is a grammar? So if it has the following properties like v, t, p and s, then you call this particular thing a grammar. Okay, so now uh, uh, what is v? If you remember, v is your uh, non-terminal. Okay, so non-terminal, non-terminal means a capital. Okay, so non-terminal is capital. So for this, from this you can what is the set of v here? So s is a non-terminal, a and b is also a non-terminal, and no other one. Okay, in the similar way, t is terminal, and this is basically the small letters, and small letters in this case is a and b. Yeah, that is absolutely correct. And p is your production rule. Just wait for a minute. And s is your start symbol. So start symbol in this one is this. Okay, so now production rules is this all the things that is written here are called a production rules. Okay, so this production rules means this particular grammar is deriving something, but I do not know what exactly it is deriving, but it is deriving something. So that particular, if you see that this is also a production rule, that s equal to a, this is also a production rule. So every line that is written in the form of this, that some variable is tending to some other variable or some other terminal or non-terminal, that thing is called your production rules. Okay, so that is always your production rules. Okay, so in this because it satisfy all the four variables, there is a terminal, non-terminal exist in the grammar, there is a terminal exist in the grammar, there is a start symbol in the grammar, and there are production rule in the grammar. So I can call this that this is a particularly this I can call this grammar, because all the four tuples are satisfied in this. Okay, so now if you are seeing, it is also written like this is your SAB. Now SAB is your V and AB is your T, and this is your start symbol, and these are your production. Okay, so they are also they already, this is a grammar, so they are giving you an example. Grammar G1 here, and now SAB are non-terminal, so I just wrote it in the form of set, but it is saying the same thing. Okay, so this is the example of a particular grammar. Okay, so production rules are look like this, that whenever there is some kind of a arrow tending towards any other arrow, that is your production rules. Okay, so now if you see that why exactly we use some kind of a grammar, so there we want to derive something from the grammar. So there are derivation, particular kind of a derivation. If you have studied about compiler design, so most of the things are based on derivations. Okay, so now the derivation from a grammar is written like this, that some strings can be derived from some other string using the productions in the grammar. So by using the production rule, you can derive some strings. Okay, so that particular strings are generated by a particular grammar. It means that that strings are a part of a grammar, and that can also be represented as a language. Okay, so what do I mean by this? Just wait for a minute. And if a grammar G has a production A alpha tends to beta, we can say that alpha A alpha Y derives A beta Y in G. The derivation is written as. Okay, so I will tell you how the derivation is done. So don't worry about this definition. It is just saying, suppose this kind of a grammar is available to you, and that grammar is written like this: S equal to A B and a, and these are the production rules that are already given to you, and a is going to epsilon. Okay, so is this a grammar? So can I call this a grammar? So just identify VTPS. Okay, so this is your non-terminal, terminal, production and start symbol. So start symbol in this is S. So this is as production, all the rules are here existed are in the form of production. And terminal, here the terminal means that the small letters is A B A. So small letter is A, you can call this okay, so you can call this that there are terminal symbols here. In the same way, non-terminal, the big letters is S and capital A is there. So you can call this that all of these four tuples are satisfied. So I can call this a grammar. So this is my grammar named as G2. So G2 is given like this, and some of the strings that can be derived from this are okay. So I'll take a little bit of a easy example to show you that it can be done like this. So just take this example as equal to ASB, and then as equal to AB, and then B tends to small. Okay, so again all the rules are there. So the non-terminals in this one is S, and there is another B, and only two symbols are capital in letter, and terminals will be your A and small b. Okay, so these are there, and your production, this production is already there, and your start symbol is S. Okay, so all of the rules are satisfied for being a grammar, so I can call this a grammar. So now what do I mean by that? That if I want to derive from this particular production rule, I want to derive a string. So derivation is based on deriving a particular string, so such that the string is AABB, something like this. Okay, so I need to verify that can I derive AAB from this particular string. So clearly see, so as uh, I am starting from the start of a grammar will always be from the starting symbol, that is your S. Okay.
So,
Yes, yes.
can you please explain production and start symbol again?
So the start symbol is the symbol that you are starting the grammar. Okay. So the product, whenever there is a production rules, there are three production rules written here. Okay. So from which production rule it is starting? So it is starting from this variable. I will call that the start symbol for this particular production is S, and I will write this. Okay. In the same way, the production is just whenever you see some kind of a uh, uh, this arrow is saying that it is deriving something. So S is deriving something, S is tends to A. It means S is deriving a terminal, a non-terminal, a terminal. So that is why that production rules are given like this. The rules, it denotes these rules denotes a particular kind of strings that comes out from this grammar. Okay, so this every grammar. So if I write this kind of a production rule, this production rule will help me derive some kind of a strings, and that strings will be part of a some particular kind of a language. That is why I say that this is a generator, and this generator generates very various kinds of string. Okay, so based on the strings, you have to decide that what particular language is this. So in that directly I can say that it is generating a particular kind of a language. Okay, so you have to identify that particular what exactly a particular language is that. So production rules are just the derivation. I just hold for a minute. I just derive it and then tell you. Okay, so if I want to derive AABB from this one, so I will always start from the start symbol. Okay, so as I'm starting, and then I will write whatever is written there. Now there is another symbol, this S. Now I want AABB. Okay, so I got a. Now I again want another A. So how can I get another A? I can get if in place of S I substitute. I substitute because S is equal to a bigger B. So if I substitute this one, I will get the two A's. Okay, so now in this place of S I am substituting. Now this A will be as it is. In place of S I am substituting A, B, and then B. Okay, in the similar way, now how can I get, now I want a B, can I get a B from it? I can if you see the production, B tends to small b. If you're seeing B tends to small b, it means I can write a small b in place of B and small b in place of B, and I got a particular string from this particular grammar. Okay, so that just let me clean a little bit of this one. Suppose you're starting from A S B. Now I want another A. So I, in place of S, I can substitute another thing, that is your AB. Okay, so if you're seeing this S is it tends to AB, it means in place of S you can write AB. In place of S you can also write ASB. There is no compulsion. Here I can also write ASB here. But I don't think if I follow that path, I will be able to derive the same string. Okay, so now if I see, now there is a S here. So if I want to stop it, I can again attempt it, but there will be three A's. Okay, so if I in place of S, I substitute ASB here, there will be three A's in the language that I do not want. Okay, so if I again put AB here, again there will be three A's I do not want. I only want two A's. So what path I will follow? I'll start from ASB. In place of S, I will substitute AB. Okay, so this is in place of S, I am substituting a AB. So it constitutes to AAB. Now the B will be written as it is. Now in place of B, what I can write, because B is again deriving a small b, so you can write it B, and then, and again in place of this B, you can also write a small b. Okay, so these forms, these particular in between forms are called your sentential form. Okay, sentential forms, sentential forms. Okay, so why exactly, why are we using grammar? So if you take a look at English grammar, what exactly English grammar is, it is a rule, it is the set of rules that defines, that generates a English language. Okay, in the similar way, now in this particular case, now this grammar represents a, this grammar, this production rule is a grammar. So this grammar represent a particular set of rules for from which a particular language will be derived. Okay, so I will tell you about, we will do lots of question about it, that for a particular language how can you write a particular grammar. Don't worry about that, but just see that you can also write this procedure as, just I just take it outside, it will be more beneficial to you if I take it outside. Just wait for a minute. Mm. Okay, so I just take the same grammar. The grammar was S tends to A S B. This is a classic example in most of the books. This kind of a this kind of example is used there. So I just want to use this particular example. So now in this, if you're seeing that I can draw a tree, so from that tree you can write from S, you are getting, what are you getting, ASB. Okay, so write it like this. Okay, so A is there. Now you need to derive A, A, B, B. Okay, so now A I got it, and I want another A. So in place of S, I am substituting this one. Okay, so now in place of S, I am substituting this. Now I got two A's. Now in place of B, you can substitute a small b. In place of B, you can substitute a small b. Okay, so now you have to do a parsing. Okay, so parsing, this is one of the most important step. If you have studied compiler, always the parsing is done like this, from left to right, and top to bottom, top to bottom. Always the parsing of a tree is done like this. I will tell you what exactly, what do I mean by this. And you should stop, uh, and you should stop and write the terminal letter. Okay, so write the terminal, whatever with the terminal node is, you just write whatever is in the terminal node. Okay, okay, so I am starting from left. So this is my left and this is my right. From left to right, top to bottom, and now I occur the terminal node here, so I write the A here. In the similar way, I parse it from left to right, top to bottom. So I'm going again top to bottom. Now again I got a terminal symbol here, so I write A here. In the similar way, again go from this left to right, top to bottom, and now I got another B here. So this is also a terminal symbol. You write it in the similar way. Go with left to right and top to bottom, and you will find A here. So B here. So write it as it is. So and again, yeah, left, top to bottom, left to right, and this one, and your tree is completed. So this is the parsing that you will always see in TOC. This kind of a parsing is always followed in compiler design also. So keep that in mind, left to right, top to bottom. And now if you're seeing why these small symbols are called terminals here, because you will always have to derive a string. So strings are always in small letters. Okay, so keep that in mind, strings are always in small letters. Okay, so if they are in small letters, you are driving a strings and they are in small letters, it means at the end of a at the end of the tree there will always be small letters. Okay, so that is why your terminal symbols are called the terminal symbols are the symbols that are at the ending position. So that is why small letters are always called the terminal symbols, and the big letters are also called always called uh, non-terminal symbol, because in the strings that cannot be a part of the language, like AASB. This is not a string. Keep that in mind. This is not a string because in this particular string there are two capital letters are coming. So that is why this kind of a notation is used. Okay, so I have derived only one, and this particular thing that I have written a tree, this is called a derivation tree. Okay, so this is called your derivation tree. Okay, so now what is the yield, what is the yield of that derivation tree? Yield of derivation tree is what string it is generating. So that is the yield of the derivation tree, and if from this derivation tree the yield is AABB. Just let me see if you have any kind of doubt. I think okay, so ask me if you have any kind of doubt. Just let me also see the chat box. Okay, so Himanshu has asked that what does production rules do? Okay, so Himanshu, it is just a set of rules that will force you to generate a particular language. Okay, so if I say that I want to generate a language that is a raised to power star. Okay, so this is a language, you know. I will write a set of production rules. Production rule set of okay, I that is a very good question. So what does production rule? Just hold for a minute. What does production rules do? I'll tell you with the example. Okay, so exactly what does production rules do? So this is also the same thing. If you take an analogy of an English language, that what does English grammar do? It is able to govern the English language, that it has to follow a particular set of rules. Okay, so in the similar way, production rules is also based on that it is it the grammar is designed in such a way that a particular language is generated. Okay, so I take a example that it will be more beneficial to you now. If I take a language, suppose this is the first language, that's one of the most easiest one that I will take, that this is the language here, where the length of the string is 2. So that is the classic question that we have done in the class. Okay, so now I will say that write a grammar corresponding to that language. Okay, so write a grammar to L. Just write the grammar to the corresponding of it. So the easiest way to write a language is easiest way to write a grammar is because this is a finite set. If you're clearly seeing this is a finite set, so just go with S starting symbol and write AA slash BA slash BB slash BB. B AB is remaining. Okay, so AB. Okay, so this then now just verify the rule VTPS. V is the terminal, V is the terminal non-terminal, so V is in this case V is S and T is terminal, so AB is terminal. Production rules are given like this, so there is an arrow here and S is tending to something, so production rule, this is production rule, and S is the start symbol, so start symbol is always. So all the conditions are satisfied if you are clearly seeing this one. Now what is exactly happening here? So this production rule, this is a production rule, is ensuring that the language that you get from this particular grammar G1. So if I talk this, give a variable name to this one as G1. So this from this G1, this production rule are making ensure that the language that you get out from this production rule is A B, and AB. So if you see that, if I use the same analogy, the analogy was that that English grammar uh, has is a set of rules that governs the English language, that a particular thing. Now in this context, if you're seeing because in TOC there are many languages. If you see, this is a language e raised to power n. This is also a language AB followed by AB or BA raised to power a star. This is also a language. So for this particular language, you can write a grammar. For this particular language, you can write a grammar such that this grammar is able to generate all the strings that is given by this language. In the similar way, this G1 is able to generate all the strings that is given by this language. Okay, so just let me see if you have any doubt. I think one more. Okay. Yeah, absolutely correct, Himanshu. The production rules is a kind of the rules that is grammar, and the grammar defines in turn the language. Okay, so if I give you a but now, if you see that for this is a grammar here, but if you want to write it in such a way that it looks good, so you can convert this because I know that this particular thing can be written in the form of a regular expression like. I can see that. Okay, okay, sorry for that. Okay, so now if you see, now the regular expression for this language, that is two length strings. Okay, so two length string is the language. If you remember, we have this is one of the first question that we have done in the starting of TOC. So two length string, it can be written like this: a plus b followed by a plus b. Okay, so this is one length and this is two length. Okay, so in the form of grammar, you can this is correct, this is not wrong, this is correct, but you can also derive it a little bit of a pleasing way that we have seen various rules like this one. Okay, so you can also write like this one. So it can be written like this, that you can write that starting symbol, there is a variable and there is a variable, and the length of the variable is two lengths. So I can write a capital A and a capital A, and this capital A exactly is A or B. You can write it capital A is exactly is A or B. Okay, so now if you derive, now I know that only four strings can be derived, so derive it. So from S you can get A, from this A you can derive A, you can tree. Okay, so top to bottom, left to right, you will get a terminal A, then a terminal B. So AB is derived from this derivation tree, and from this one I can derive AA. S tends to AA, and this A can be B or this can be A. So again, top to bottom, left to right. So this is B and this is A. In the similar way, this is again S tends to AA, and A tends to either A or B. So this can be a B and this can be a B. I think you get my point. Okay. So don't worry, this is not wrong, but this makes more sense. Okay, so I will prefer this one over this one. This is not wrong, so this is that. Okay, so now understand this. I again, at the risk of repeating myself, I just want to say that a grammar is a set of rules. Okay, is a set of rules for generating a particular language, for generating a particular language. Okay, so there can be any, because if you see that English is only one language, but in TOC the language set can be anything: L1, L2, L3, L any. There are number of languages exist. For every particular kind of a language, you have to write a particular grammar. So there is nothing like that for every language you can write one grammar. So for every language you have to write a different grammar. Okay, so in the building block, I will start with the language that is the building block of it. So I will, there are three building blocks. So the first building block, okay, so the first building block is your, okay, sorry for that. Okay, so the first building block is you have to start is uh, for you have to write a language for the grammar for so sorry you have to write a grammar for the language that is a raised to power n, where n is greater than equal to 0. Okay, so how can you write it? First derive out what the language is. So the language looks like this: a, so any number of a's you know about this. Okay, so you cannot now, if you're thinking like this, that you cannot write the language like this a, so because it is not a finite set, so you cannot keep on repeating. So grammar cannot be if you're saying grammar cannot be in the form of n that we will see after that, so that is not correct. Okay, so keep that in mind. Now how can I do this? So this is the first building block, keep that in mind, and this kind of a thing is always used. So this keep in mind this expression. I will explain about this expression. Take a look at it, and keep in mind, because most of the language will contain a raised to power n in symbol. Okay, so now see, you can derive the language like this, that uh, because you want any number of a's, so start with this starting symbol, then write a, and then write s again. This and this are repeated, and in the end, or because it is a star a star, so a raised to power 0 can also happen, so epsilon can also be in the language, so write a epsilon. Okay, so that is the grammar for this particular language. Now see, it is or you can also write it like this: s goes to sa, and it is again. Both of them are correct. I will tell you how this is correct. Or you can use another variable also. So you can also use a equal to a and then epsilon, or a equal to a then epsilon. So there is no compulsion on variable. So variable, you can use any variable, but because you are starting it, I will always prefer a s. There is no compulsion that the starting symbol will always be s. It can be anything, so there is no compulsion about it. Okay, so now see how exactly it is deriving all the strings. So just write a try a derivation tree. So if I start with s, from s I can directly go to epsilon. So epsilon is in the language, so epsilon is derivable from this. So top to bottom, so this is a terminal you will get. So terminal, keep in mind, epsilon is also a terminal symbol. Okay, so every string that is a part of the language is terminal. Keep that in mind. So every string that is a part of a language is a terminal. So just write every string. Keep that in mind. String is always in small letter. Okay, so right now s can derive as. Okay, so if I want a 1a, you just write a epsilon here. You will get a 1a. Okay, so if you want two a's, you can get two a's, as, three a's if you want, four a's you want. Okay, but in the end you have to stop it. So if I parse it, so I will get a, yeah, absolutely. Top to bottom, left to right, I will get a, absolutely. A, I will get a, top to bottom, left to right, a. Now again I will get a. But again, this is not a terminal symbol. So your parsing will throw you an error here, because this is a non-terminal. So you have to stop it. So use a epsilon here. So derive it epsilon. Now parse it. Now we'll get a epsilon. So epsilon. So now complete it. Okay. So now the answer is a. So you are able to derive any kind of a number of a's from this one. So you can write the grammar here. So the grammar is exactly written for this language only. Keep that in mind. This grammar correspond to this language. In the same way, if you say this is also possible, because it will look like this: sa, 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 sa. Okay, so in the end you have to write epsilon in this one. Top to bottom, there is no terminal. I am about to find this one. This is one terminal I find, so write it. This is again another terminal. So A, another terminal A, another top to bottom, left to right, A, another terminal, top to bottom, left to right, A, A, and then go. Okay. So you are able to find the 4 A's. Okay. In the similar way, you will be able to derive any number of A's, because this particular language belongs to A raised to power n. Okay. So that is also correct, that is also correct, but if you want to change the variable also, this is also correct. Okay, so keep in mind that this is why I'm calling this a building block, because in most cases you will use this kind of a scenario. Okay, so keep in mind as. Okay, so now I think there is another building block for second one. I just tell you the second building block. After that, you are on your own. Okay, so I will give you a question. Just derive the language corresponding to that. Okay, the second, there are three building blocks that I want to tell you about. So I will first of all I will only tell you about two. Okay, so the second building block is for this language. So this is also the most occurred expression, regular expression that you will find. Okay, so this is a language. I can also call this a language because I am able to generate many strings from this particular language L1. Okay, so now corresponding to that, it is exactly if you see that this is exactly, you can write this A star plus B star raised to power a star. Okay, so it means that for this, it is again it is, you can think of it like this: A raised to power n plus B raised to power n raised to power n. So this is again a building block, this is again a building block, and this whole, keep it mind it whole, it is also a building block. Okay, so you can again, the use of this is again used, the A raised to power n is also used in here. So just don't worry about that. Okay, so if you write it like this, because if you remember the regular identities, regular expression identities, it can be written like this. Okay, so for this you can write, you can go from the start symbol. So I will go for the start symbol. For this A raised to power n, you can write as. For this B raised to power n, you can write bs. Okay, so for this one and the end, you can write, because this is raised to power a star here, so epsilon will also be a part of the language, so you can write epsilon. Okay, okay, so now if you see, if you are able to derive, so it says that any number of a's, any number of b's can come in any direction. So ba can also come, it is also possible. After number of a's, b can come. After b, any number of b's, a can also come. So this is the main part here. Okay, so just write a derived tree, try a derivation tree and see that if particular this particular language is able to, this particular grammar is able to derive this string, so it means that it is generating correctly. Because I know if a raised to power s, I can get a raised to power n from here and b raised to power n from here, but can it do that after b, a can also come. Okay, so just write it like this as. Now it will be, if I want to start with the a's, you can write as. How many a's I want? I want two a's. Okay, so 2, 3 a's I got it from this. After that I want 3 b's. Okay, so what you do, you write bs, bs and bs. So three I got 3 b's. Now I again want a's, 2 a's. Okay, you can get a 2 a's because s tends to either as or bs. Okay, so it means that you can get as and as. Now if you want to stop it, you will stop it with epsilon. Okay, so now if you parse it, you will get a, top to bottom, left to right, a, b, 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 a, and then epsilon, and then all that passing tree. So this kind of string is also generated by this. Okay, so you can consider this one as another building block, because I providing why I am saying that this is your building block, because most of the question that you will see, they will always follow a raised to power n and a raised to power a plus b raised to power star. So these two kind of expressions are very widely used. So that is why I'm calling this a building block. Okay. So now I think you have understood the question. Now try to write the grammar. I try to write the grammar for at least of length 2, at least length 2, if you remember. Okay, so just try it. I think the regular expression I'll write it so it will be easy for you. So first of all, this is one length, this is two length. After that, any number of strings can. Okay, so just try to write the language and send me a screenshot or send me anything that you have done. Okay, so just post your screenshot in the chat box. Okay. Okay, okay. So if you not understand it, just take a look at the length. So this is one length, this is two length, and this is your three length. So at least three things will be required here. And this is again the building block is already there. Okay, so a plus b star is in that, and you will need at least three variables. Okay, so I will start with the same symbol, and this variable will be same to this variable. So I can say that this, because this is a plus b and this is a plus b, they are one and the same thing. So you can call it like a, this is my a, this is my b, and this is my s. So define every a and sorry for that, it cannot be your s because it will indicate totally different thing. So it will be another variable like b. So I'll take another variable like b. Now what can I do? So for this, if I say this one as a, this one as a, and this one as b. Okay, so for this a, I know that only a or b is there, or a or b. Okay, so for this a, I can guarantee it like it can be a or b. Okay, so plus means or. So this is defined here. Another b. Now this is a building block. If you remember, this is a building block. So what is that? When there is a b here, it is s. Now this s is repeated here, s is repeated here, and there is epsilon. Okay, so you can write, because this is a variable b, so a b is repeated there, and another for b is repeated there, and there is a epsilon. Okay, so you can write your grammar like that. Okay, so just to be sure, again this is one and the same thing that many of you will get a different grammar from my side, that I have derived a grammar that can be different from you. Okay, so don't be hesitant. If you have designed a grammar, just post your screenshot. I will tell you by again deriving a particular strings, that this particular grammar is deriving the string that is not in the language. Okay, so I think that is the thing. So again, another language is derived by Mayank. Just let me see that it is SAAB A B B, then there is B A B, and then there is B B B. Okay, so now the B is corresponding to A B B B. I think that is very correct. Okay, so that is only pointing to A plus B star. So that is the same in my side also. Okay, so now here again, okay, so I think that is also correct because what Mayank has done that there are only four possible strings are possible. So he has written the strings in here. Okay, so that is also correct. This grammar is absolutely correct because all the languages that is generated from this one is also satisfied by this. Okay, so this is also correct and this is also correct. Okay, so in this, just try to use a set of variables that will be very beneficial because if you write the grammar like this, you will be able to understand it. Okay, so this is correct, but I prefer if you use variables. Okay, so that will be eliminating for you. Okay, so now if I try the fourth one where I write at most the same thing that we have done earlier, at most length of, can you write a grammar? So I just write a regular expression. It will be at most length 2 will be uh, epsilon will be there and a single length string and most. Okay, so it will be, yeah. So you can write it like this: a plus b plus epsilon and a plus b plus epsilon. Okay, so this is your regular expression and try to write a corresponding grammar related to that. Okay, try it. Okay, so think of it like it is again one length and this is again a two length. So you can because this is one and the same thing, so you can think of it like a variable, that is this is your a and this is your a. So you can start with a symbol and you can write a, and for that a you can write either it can be or it can be a small b or it can be an epsilon. Okay, so now if you drive, you will get maximum of two length string, but you can also get a epsilon because a tends to a epsilon here, a tends to epsilon. So epsilon is in the language. You can also get a single a, so single is also in the language, so single b can also be in the language, and epsilon is already here. Okay, so if you want to generate a two length string, so in place of this epsilon write a, in place of this a write a b. Okay, so just think of it like this. Okay, so we will do more practice in the coming lecture, so don't worry about that. We will do plenty of practice, so you will understand this concept. Okay, so thank you for listening, and you can move on to the next lecture.